Hai, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good morning to everyone that's watching this video. Thank you for joining us today. I am Amir Hassan, and here to present to you an overview of Pesada Dunia Distribution Center. Uh, this 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 project is about mineral water distribution center, and I invent the system during my internship around 2019. It's about 6 months of my internship, and here we go to the next slide. So this is my group members. My name is Amir Hassan, and group member two is Anik Amshar, and number three is, and the last member is Akil Irfan. So So the background for my company of distribution center is it's a company that involved in the distribution and sales of mineral water. This company acts an intermediary between the mineral water fetchers and retailers or consumers. They source mineral water from various brands or manufacturers and distribute it to retailers such as grocery stores, convenience stores, hotels, restaurants, and other establishments that sell bottled water. Um, not forget to not forget to that they distribute it to public and private schools, universities, and offices. They have their own fleet of vehicles or that pro, uh, that provides that provides to um, distribute the mineral water to different locations. They handle the logistics, storage, and inventory management of the water bottles, ensuring that they are properly stored and delivered in a timely manner. In addition to supply retailers, some distribution centers may also cater to individual customers by delivering mineral water directly to their home or offices. They may offer subscription service or one-time purchases depending on the customer needs. So that uh, that means my company uh, my company like this. My uh, It means like the customers can go to the company and buy through, just like uh, as a mineral water distribution center. Sada Dunia Enterprise likely plays a crucial role in ensuring a steady supply of mineral water to the market, meeting the both businesses and consumers. They may prioritize maintaining product quality, managing relationships with manufacturers, and providing reliable and efficient distribution services to their customers. So we're gonna go through the history of the system. In the early stages of operation, Pesada Dunia may have relied on manual processes for inventory management, order processing, and distribution. Uh, just like they record um, the stock storage. In the early stages of operation, Persada Dunia Mineral Water Distribution Center may have relied on manual processes for inventory management, order processing, and distribution. This could involve maintaining physical records, using spreadsheets or basic software tools to track inventory levels and manage orders. Throughout the system of Persada Dunia Mineral Water Distribution Center, there would likely there would likely have been ongoing upgrades and improvements to meet changing business and technology advancements. The specific timeline and details of the system implementation would depend on the company's growth, resources, and strategy priorities. So let's move on to the next slide, which is operation. So the operation, basically, this is a common operation that used on my system, which is mineral water. For mineral water is for adding a brand, describe a volume, and put a price on put a price tag on a mineral water. Next is dispenser. What type of dispenser, the volume, and also not forget the price. For drivers, uh, we need to record the ID, the name of the driver, the logistic they use, the location of their delivery, and put their delivery time and their delivered to the location time. So last but not least, the client, which is um, the client ID, the client name, for the client order name, order ID, and delivered time. So they retrieve the um, retrieve the retrieve the item at what time. So that's all. Let's move on to the next slide by Akid Irfan.
Hi, Assalamualaikum guys. My name is Akil Irfan bin Makranwa. I will be explaining to you guys about the operation that being used in this project. The operation that being used in this project is push and pop. So, shall we begin? Uh, First of all, I'm gonna explain about push first. Push, in general, is a method that adds a specific element to the end of the stack and return the new length of the stack. The way that more understandable is the first data of your data will be stacked by the new data of yours shown in the slide. For example, build a building. The first floor is your top, and then the management decide to build a new floor. So the second floor will be the new top of the building. That is the way how push operation is operate in your data basically. So next we move on to the slide. So as shown in the slide, the the currently is the top data is A, and then we add B as the new data. So B will stack and become the new top data, same as shown in the slide. C become the new top, D and E become the new top by using the same operation as A and B. So now we move to pop. I will explain to you guys about pop. Pop in general is a method to remove the last element from the stack and return that value to the caller. If you call pop an empty stack, it returns undefined. The same the same operation that similar to POP is array, prototype, shift. They have the same behavior as top as POP, sorry, but apply to the first element in the array. That's for array, prototype, shift. The POP method is a mutating method. In the easiest way to absorb the knowledge is POP. POP is remove the current top from your current data. For example, a building has 5 building, and then the management to decide demolish the 5 building. So the level that before 5 level 5 is level 4. After the management demolish the 5 level 5 level 5 floor, then the level 4 will become the new top. That's the easiest way to understand the operation of pop data. So as you can see in the slide, b b data has been removed, and then a become the new top of the data. Next, we move to running time and estimate the efficiency. So before we go to the coding, we need to understand the concept and basically how we get the equation for this project. So in this slide shown that n minus 0 plus 1 and minus 0 is equal to n minus 0. N minus 0 is equal to n minus 0. N minus 0 and is equal to n minus 0, and so on. And we get the equation for the data for our project is 7n plus 1. Fn equal to 7n plus 1 is equal to On. So we can move to the code. Q string Q is equal to new linked list string. Create new queue. This is to create the new queue for, and the variable that we use is string, and this which is basically an object. Next, we move to get the operation from the queue. We use for integer 1 is equal to 0. String operation is equal to q. If operation dot equal remove. String remove element is equal to q remove. Remove the first element and perform necessary action with the removed element. Otherwise, else if operation equals update. String update element, new element. Add q add update element. Replace this with the code that been used before, which is the remove element. Add the for q add the update element to the end of the code. Perform any necessary action with the update element. Next is else if operation. We use string and then first element q that is equal to cubic. Get the first element from the code and perform any necessary action with the view element. So we're moving on to the findings that we can find from based on the code. We can conclude that the running time of the algorithm for the distribution system using Java stack is On, where n is the number of items in the system. The linear time complexity of the algorithm makes it very efficient and well suited for handling large volume of items. Next, additionally, the use of stack data structure provides a simple and effective way to manage the flow of items in LIFO manner, ensuring that the most recent received items are the first to be distribute. Therefore, asymptotic behavior of Fn equal to 7n plus 1 is described by Fn equal to n, and the algorithm is linear time algorithm. That's all from me. Thank you.
My name is Anik Amshar bin Muhammad Anizam, and I shall explain the code for our application today in this presentation. Here we see import Java util linked list and import Java util queue, which is the Java packages. And here is the uh, access modifier, public class, and here is the class distribution system. And here we see the queue item queue, which is the object for the code, and queue string item queue equals new linked list is the object creation. Item queue dot add item 1, 2, 3 are the object based variable. And here, while item queue is empty, is the queue. String item equals item queue dot pull is the object creation, and system dot print in distributing item is the access class attribute using the object class. Basically, the object would be filled with in item 1, 2, 3, and then through queue it will print out. It will print out during the distribution. All right, output, and this will be the output for the codes. So basically, the collection class used in this example is the linked list class, which implements the queue interface. The interface, and the queue interface provides operations such as add, remove, peek, pull for the managing queue. The interface used are queue and list. The queue interface provides the following operation for the queue. Add EE, it adds the specified elements to the end of the queue. Offer EE, it adds the specified elements of to the end of the queue and returns true if the operation was successful. Removes, it removes and returns the elements at the head of the queue. Next, pull, it retrieves and removes the elements at the head of the queue or returns null if the queue is empty. Element, it retrieves but does not remove the element at the head of the queue. And finally, peek, it retrieves but does not remove the element at the head of the queue or returns null if the queue is empty. Right. Now, moving on, here is the list interface provides the following operation for the managing the list, which are add EE, it adds the specified elements to the end of the list, add int index E element, inserts the specific elements at the specified position in the list, remove object O, it removes the first occurrence of specified elements from the list. Remove int index, it removes the elements at the specified position in the list. Get int index, return the elements at the specified position in the list. Set int index element, it replaces the element at the specified position in the list with the specified element. Index of object O, it returns the index of the first occurrence of the specified element in the list. And finally, size, it returns the number of elements in the list. So, in conclusion, in this project, we explored a computer application that uses a specified data structure, which is the queue, to manage the distribution of goods from a warehouse to a different locations. So, in this case, we're distributing water to different locations in Klang Valley. All right, next it's discussed the importance of data structure in computer science and their relevance in the real world application. So, in the application for this computer application is to ensure that employees do not make any mistakes in making the wrong deliveries, such as or making the wrong delivery brands of water to the wrong place of the wrong location at the wrong time. Okay, and finally, it also showcased that the practical implementation of data structures in a real world scenario and the benefits they bring to the system design and optimization. It, we hope that this application does not make. We hope that this application does makes the flow of distribution of water much more simple and easier. That is all for our presentation. Thank you for watching. Make sure to like and subscribe, and also give us a comment if there's something interesting to be shown. Thank you.